All right, so we're going to review solving quadratic equations by factoring. So all of these quadratic equations can be factored, and we just have to find ways to do that. So what we're going to do is look for factors of 15. And those factors of 15 have to sum to 8. So looking at that, I could have 1 and 15, but that, when I add them together, makes 16, so that doesn't work. 2 and 8, but I add 2 and 8, and that makes 10. So how about 3 and 5? Well, 3 plus 5 makes 8. So what you do then is you make your factors x plus 3 times x plus 5 equals 0. And what you can do is you could distribute this, and it would make x squared plus 3x plus 5x, which would be x squared plus 8x plus 15. But the cool part is if you multiply two factors together that make 0, we have two equations that we could solve. You could solve here x plus 3 equals 0, and subtracting 3 from both sides, you would get x equals negative 3. And then here, if I solved x plus 5 equals 0, you can subtract 5 from both sides and get x equals negative 5. So if you notice here, we have our two solutions, x equals negative 3 and x equals negative 5. Now, for this second equation, what I notice here is we have 5 on the right-hand side. So I'm going to have to subtract 5 from both sides, because in order for this to work, this has to equal 0. So if I do 12 minus 5, 12 minus 5, we would have x squared minus 8x plus 7 equals 0. Now, if I notice my two factors here, if I'm factoring that, I need factors of 7 that add together to be negative 8. Well, they're both going to have to be negative, and the only factors are negative 7 and 1. So this would have to be x minus 7 times x minus 1 equals 0. And then you take these two equations and take these two factors and set them equal to 0. So we have x minus 7 is equal to 0, and x minus 1 is equal to 0. So again, here you can show this step if you have to. Add 7 to both sides. That makes 0. And you get x equals 7. Add 1 to both sides, and you get x equals 1. And then on here, if you're solving this, we're looking for factors of negative 11 that add together to make negative 10. Well, I know for that to happen, one's going to have to be negative and one's going to have to be positive. So because this is negative and 11 is prime, the negative number is going to have to be bigger. So I can make this as x minus 11 and then times it by x plus 1 is equal to 0. And if you factor that out or expand it, you'd have x squared minus 11x, but plus 1x would make minus 10x, and then minus 11. So now you set these two factors here equal to 0 and solve. So x minus 11 equals 0. So I'm going to add 11 to both sides. I don't really have space. So I'm just going to write x equals 11. And then here I set this x plus 1 equal to 0. And then I subtract 1 from both sides, and you get x equals negative 1. So there's my answers. I have 2 of them. Now here, if I have 49 minus x squared equals 0, well, the first factors, this would be a perfect square. We could do 7 and 7. And then to make minus x squared, I can go 7 plus x and then times 7 minus x. Remember, that's our perfect square pattern. The square root of 49 is 7. the square root of negative x squared is going to be x, and then we have a plus minus because we would have 7 times 7, 49. 7 times minus x would be minus 7x, and then plus 7x would make 0 on the x term, and then positive x times negative x would make negative x squared. So if I'm solving this now, and I'm going to write over here 7 plus x equals 0. So I'm going to minus 7 from both sides to get x by itself. And we have x equals negative 7. And then down here, if we have 7 minus x equals 0, we can actually move the x to the other side. Oops. And that would be 7 equals x. So my two answers here, we would have x equals 7 and also x equals negative 7.